You have to say that again.
Okay, so we're going to solve absolute value inequalities and equations today. Now, I'm going to give you some step-by-step instructions that you can use every time, whether it's an equation or an inequality. It doesn't matter. You're going to follow the same steps, okay? So, when we do some of our examples, some of the steps won't apply, but when we have an example that it does apply, you'll already have your steps written out, okay? So the very first thing, first let me even show you what one of these looks like. So maybe we'll do an example as we sort of write out our steps, okay? So here's our example problem. I'm going to kind of write that on the right-hand side, and on the left I'll write the step-by-step instructions. So let's just say we were going to do something like, okay, that one looks pretty good. The absolute value of 2d minus 8 is greater than 12. Okay? So here we have an absolute value inequality, and I need to solve for d. All right? So the very first step is going to be to get the absolute value alone. In this case, it already is alone. I don't have like 2 times the absolute value of this, or 5 plus the absolute value of something. We'll do an example in a few minutes where I do have something there to get rid of. But right now, the absolute value is all by itself on its side of the inequality, so step 1 is already done for me. Okay? Step 2. Ready? Once you have the absolute value alone on its side of the inequality sign, you're going to rewrite the inequality twice. Once, exactly like you see it. Rewrite the inequality exactly as you see it. But without the absolute value bars. I'm going to explain why this is at the end of this, okay? Because I want you to understand why we're doing what we're doing. But for now, let's just get the steps down so we have them all in one spot, and then we'll talk about why. Okay? So, step 2 requires me to write my inequality just like I see it, but I'm just not going to write the absolute value bars. The second time I rewrite it, so that'll be step 3, rewrite again without bars, but this time flip the inequality symbol over and take the opposite of that side. What are you even talking about, Miss Sabia? Don't worry. I'll explain it in just a minute. So let me give you a second to jot that down, and then I'll show you in math what I mean. Okay, so I'm going to write it the second time over here. Again, exactly like I see it without the bars, so 2d minus 8. But this time, I'm going to flip the inequality symbol over, and I'm going to take the opposite of this side. So now I want negative 12. I promise I will explain why you do this in just a moment. I just want to get our steps down. I know we got a little bit of a glare. Can everybody see okay? There we go. This is the most crucial step. If kids make a mistake, it's right here because they don't do step 3. They don't rewrite it, flip the symbol over, and take the negative. So don't you forget step 3. Now, step 4, you're just going to solve each inequality like you normally do. Solve each separately. Okay, just like we've been doing, so I'd add 8. Divide by 2. So on one side I got d is greater than 10. Just go ahead and solve the other side again, just like you normally do. And now we're almost done. But here's where you gotta put your thinking caps back on. I have d is greater than 10 and I have d is less than negative 2. Your answers to these are going to come out as either ands or ors. It's up to you to figure out which it is. Well, how do you know? You just ask yourself, are there numbers that are greater than 10 that are also less than negative 2? No, there are not. So in this case, this must be an OR. Okay? So that is step 5. Determine if you have, or let's say, determine if your answers support an AND inequality or an OR inequality. And you do it exactly the way I just said. Are there numbers that fit both? If there are, it's an AND. If there's not, it's an OR. It's as easy as that. Yep. Oh, sorry. Are there numbers that satisfy both? At the same time, then it's AND. If not, it's OR. Let me zoom in on that a little bit just so you can see it. Okay, so if we go back to ours, we already determined there are no numbers that are greater than 10 that are also less than negative 2. So my answer is an OR. And when I go to graph this, I'm just going to have negative 2, 10. I want the numbers less than negative 2 and greater than 10. There is my graph. So it's just the two bars going apart from each other. Done. Okay. Now what I want to do is get into why you do this. The problem that a lot of students have with math is they can do this. You can follow instructions, right? But if you don't know why you're doing it, as soon as we're done with this test, you're never going to remember why you're doing what you're doing. So I'm going to try and explain to you, why are we flipping this over, taking the negative? Right? We're not just doing it because. So let's start with an example. If I take the absolute value of some number and I tell you that it's equal to 8, what could that number be? 8. Or it could be negative 8, right? Because the absolute value of negative 8 is also 8. So x could be 8 or negative 8, right? Let's try an inequality. Let's say I wanted the absolute value of some number to be less than 10.
What are you explaining here while writing this?
Why you're doing all these steps. So give me a number that works here. 4, right? The absolute value of 4 is certainly less than 10. Negative 4. Isn't the absolute value of negative 4 also less than 10? What about the absolute value of something like negative 15? No, right? Because once I plug that, even though negative 15 is smaller than 10, when you go and take the absolute value, it's not anymore. Because once you go into negative land, doesn't everything flip around? Yes. So here's what we have. If I follow the steps that I talked about up here, right? If I rewrote this twice, once just like I saw it, without the bars, but then once, the second time you rewrite it, you flip the symbol over and make this negative. Now let me ask you, are there numbers that are less than 10 that are also greater than negative 10? Do numbers exist that are less than 10 that are greater than negative 10? Yes. This is an and. So I would write this like this. Oh, sorry, negative 10. So the answers to this one is anything in between negative 10 and positive 10. Try it. Give me some number between negative 10 and positive 10. 9. Plug 9 in. Is the absolute value of 9 less than 10? Yes. Negative 9. That's still in this range. Is the absolute value of negative 9 still less than 10? Yeah. So when you rewrite it this second time, there's this whole other... You can take all these negative numbers and take their absolute value, and it still works out. So this is incorporating everything on the negative side. So I'm getting all of the numbers that will work, right? Because it's not just positive numbers that work here. There's a whole bunch of negatives that work there too. Okay? So when you rewrite it the second time, we have to flip the symbol over because we're going into negative land where everything is mirrored over. Right? Think about it on the number line. The further you go to the left, the numbers are getting smaller and smaller and smaller and smaller. You with me? Okay. So let's... Sure.